Greetings. My name is Eddie Kenyon, and I am the project manager for NASA Space Academy's Team 32. And this presentation is a recap of the plasma mission concept, which Team 32 came up with, and I'll get to in a little bit why we called it plasma. First, I'd like to go with an overview of today's presentation. I'll begin with an introduction of our team. I'll talk a little bit about the mission concept summary. I'll give you some background on Titan. Spoiler alert, that is our landing site. Then I'll follow up with the mission objectives for Plasma, the payload for Plasma, and I will conclude with a very interesting instrument that our team put together called the MCVAD. Alright, so let's get started. So here is our Plasma mission team organizational chart. While we didn't follow this to the T, this helped us decide exactly what groups each person was going to be working in, and it helped us design subgroups for smaller meeting groups because it was difficult to get each member in our team to meet virtually at the same time. So up top is myself, project manager Eddie Kenyon, and here we see it's built kind of like a person. That's how I envision this organizational chart. And the left side, or kind of like the left arm of the body, is held up by our engineering team, which is led by our design deputy, Christina Leon. And she actually is also responsible for all of our CAD drawings done through SolidWorks. And she worked alongside herself, Sean, Lafayette, Estefani, and myself with the engineering group. Now, mirrored on the other side of that is our science team, and you'll see there is quite some overlap, as our chief safety officer is Lafayette Vu, and he's in charge of helping the science and research team as well as the instrumentation group. And we see a lot of the same names here: Vanessa, Lafayette, Sean, Christy, myself. And in the middle, kind of the heart of the operation, the body, is our administrative group, and that's what really holds everything together. That's led by our deputy project manager, Vanessa Salandez, and she also worked very diligently on our budget and our documents with Christina and Alexander. So that's just a general introduction of our team. Next is our mission concept summary. So our mission was to design and engineer a state-of-the-art probe to explore Saturn's moon, Titan. Now, the reason why we want to explore Titan is because it's got a very nitrogen-rich atmosphere, which could be of interest to us for numerous reasons. Now, we wanted to achieve multiple objectives, not just one, with the following constraints in mind. So we were given a mass constraint of 400 kilograms, a volume constraint of 8 cubic meters, and from the separation of the orbiter, our budget was $350 million US. So here in this image, I have circled Kraken Mare, which is the lake that we plan to land at, and the coordinates of it are approximately 68 north and 310 west. Next, I'd like to talk a little bit about Titan's atmosphere and why Titan is so interesting to us. So similar to Earth, Titan has a very nitrogen-rich atmosphere, but Titan's atmosphere is actually 95% nitrogen. It's a little bit less than 5% methane and less than a percentage of other gases. So on this slide, I included a diagram that is a representation of our understanding of Titan's atmosphere. Now, Titan's surface does have methane lakes. One of those is Kraken Mare, where we plan to explore. We also plan to investigate cryovolcanism, and those are ice volcanoes that release chilled water rather than lava, which we see here on Earth. Titan's surface temperature is 95 Kelvin, and if you do the math, it's a chilling around negative 220 degrees Fahrenheit, so it's not quite comfortable. And their atmosphere experiences photodissociation. That's when the sun's UV light collides with high-energy particles accelerating in Saturn's magnetic field, and that results in nitrogen and methane molecules splitting, which further results in a thick, hazy smog, and you could see that depicted in images taken by the Cassini flyby mission. There is a complete absence of oxygen in the atmosphere, eliminating the risk of combustion. And like I mentioned, Titan was visited by the Huygens probe in the Cassini-Huygens mission in 2005. Unfortunately, they lost contact with Huygens almost instantly after touchdown. Alright, next I'd like to talk about the 4 main mission objectives for Plasma. The first one is to analyze the cryovolcanic plumes and also analyze Kraken Mare itself. We'd like to study the aerosol properties and cloud physics of Titan, and that is something that the Huygens probe was working at doing. We'd like to determine the approximate depth of Kraken Mare and map its floor. And of course, we want to take plenty and plenty pictures. So here I included the exploded view of our full assembly of Plasma, courtesy of Christina Leone. So finally, we'll get to why it's called Plasma. Now, Plasma is actually an acronym for our main instruments that we have on board for our payload. So we begin with the Panoramic Imager, or the PANIM, which is inspired by the NASA rovers, the Mars rovers. We also have the LiDAR, and that's light detection and ranging, the alpha particle X-ray spectrometer, which will be found inside the MCVAD. We have our high gain antenna here. Our sub-imager is also within the MCVAD, and this is our MMRTG, which is our multi-mission radioisotope thermoelectric generator. Quite a mouthful, but it is what's powering Plasma, and it is extremely necessary. So these instruments were picked very carefully by our design team to fit within our constraints, whether it be budget, mass, volume, and all of these instruments meet at least one objective for a mission. So finally, I'd like to talk about our last instrument, and that is our MCVAD, which stands for the Mare Cryovolcanic Analysis Device. So this is an autonomous liquid subsurface vehicle, which is umbilically tethered to our floating lander. So let me go back to our floating lander, which is this here, which will float on the surface of Kraken Mare. So attached to its bottom, which you can't see in that image, is our MCVAD, and it is equipped with twin LEDs and the sub-imager instrument on the front, which will help us take pictures within Kraken Mare. On its bottom is a split beam echo sounder. Now this is to help us determine the depth and measure any abnormalities in the subsurface of Kraken Mare. This instrument meets multiple objectives, and it was the last instrument that we put together. Now, there are some things that we do wish we can improve with it, with help from research, and one of those is using the alpha particle X-ray spectrometer within inside of it. Now, the alpha particle X-ray spectrometer sits inside the MCVAD, but it needs to come in direct contact with dry sediment to analyze it. So that is one last bridge that we need to build for this instrument. And finally, we would like to observe cryovolcanism with its LED and its subsurface imaging lens. And that is a basic summary of the MCVAD instrument, which was an idea born by our engineering and our science team together. And finally, I'd just like to say a special thanks to everyone in LaFam. Dan Garcia, Sherry Boonstra, you guys have been an immense help, as well as our mentor, Dylan Arnest, and everyone in Team 32. Onward to Titan.